select the coin, click the Add Script button, and we want to create a new script called coin.gd. Empty template as usual, click Create, create that new script. I'm going to close the other tabs and expand the script editor. Now, we want to store a reference to the animation player. So we can use an onReady variable. Let's write it and I'll explain how it works. So onReady variable, animation player, colon, it's going to be of type animation player. And we're going to get the node animation player, like so. So here's what it's doing. onReady is syntactic sugar to run that code here before the ready function, but when Godot is going to call this function ready. Remember, it's an automated callback that is built into the game engine and specific to Godot. So this allows us to call a function like getNode that we would normally need to call in the ready function and to store the result in a variable. Meaning that when we do that here, we get that animation player node, our animation player variable becomes a reference to this animation player node in the scene tree. We're going to use that one when something collides with our coin here. Let's go back to the coin in the view. We're going to update the area to these collisions in the collision tab, and it's going to not be on any layer. Well, it could be on the coins layer here, and it's going to mask the player. It's going to detect collisions with the player. And then we're going to use the body entered signal that we're going to connect to this coin itself. So whenever a body enters the area, whenever the player hits the area, we are going to play that fade out animation. So click connect, select the coin itself, and here I'm going to rename the method. We don't need the name of the node in there. OnBodyEntered is enough because we are connecting this node to itself. Click connect to create the function in here, and we're going to use our animation player, animationPlayer.play, and you can see Godot autocompletes the animations. We want to play fade out. I want to do one last thing. It's making it so when we play the game, the coin will automatically play the bouncing animation. You have a button right next to the animations drop-down list that allows you to autoplay an animation upon loading that node. So you want to make it active for bouncing. And when you expand the list, especially if you have lots of animations, you will see that the animation that will play by default will be shown here. With that, let us test our coin. Go back to the level template, and we're going to search for our coin.tscn, place it in the game world, and we can select it, drag it around, and Control D to duplicate it. So I'm going to make 3 coins. Now we can test the game to see our coins in action. And that's the part I forgot. Yes, that is why we should not animate the area to the node straight. Remember, I told you that we are directly modifying the position of our node here. Well, when you place the node, the coin, somewhere in your level, you are changing its position. You can see the position is over 1000 on the x-axis here, for example. And our animation in the animation player is going to reset the position of the node. Let me right-click on a coin, set editable children to show you. I'll select its animation player, and look, as soon as I click on the timeline, the node jumps back to the origin, and it's animating and it's there. It's just at the top here, right next to the origin. So we have to go back to the coin scene to change that animation so that we don't animate the area, but that we animate the coin sprite. To do so, it's not that complicated. You can change your animation paths anytime. So you select the animation player, and you see where you have the position here. I'm going to click on the double arrow to expand the area. You can click where you have that position, and you actually have some kind of code for the path to the property that you are animating. I'm going to replace the dot with the name of the node that I want to get to. So dot would be the parent here, the root of the scene, I think, coin. But if you replace it with lowercase coin, it's going to animate this sprite instead. And you can see that the animation player created a second category that shows the icon of the node we are animating. So now you can see we're just animating the sprite without moving the collision shape 2D. And we're going to do the same on the fade out animation. It's not necessary. It's good. So we just have to change that track. Press F5 after having done so, and now you will see your coins bounce. And when you touch a coin, it's going to fade out. The fade out is a little too slow. So I'm going to go back to the animation player, fade out animation, and select, like click and drag to box select the two keys, shorten the animation to 0.4 seconds, let's say, and reduce the animation length. Press F5 to play it again, and now when I go over the coin, yes, they fade. This is enough to get started with the coin, let's say. We have our animated coin that we can collide with and make disappear. One last little note, if we play the game, let me show you that that animation call function track is working. So when you test the game, in the editor, in the scene tree, you have two tabs that appear, the local and the remote one. Local is your game, basically your scenes that you are creating in the editor, and remote is the actual scene tree in the running game. All the scenes that you create in your editor get converted to that big tree of nodes that are running in the game. You can see that we just have a root added to our level template scene here. But look at the coins. When I move the player and go over coins, at the end of the animation, the fade out animation, they disappear from that tree. They really get deleted, and that's what the Q3 function does. It makes the object delete itself, or asks Godot to make the object disappear at the end of the frame or whenever it's possible performance-wise. So you can see that the animation player is really doing something that is like code. It's just not written with text. But with that, we can move on to the next part, creating the portals that will allow us to teleport between levels.